Everyone and welcome back to my channel. Now on my channel, I am also going to include science topics. So today's topic is based on physics and the topic is motion. So what is motion? If a body changes its position as time passes with respect to surroundings, it is said to be in motion. So if there is a body in motion, there is also a body in rest. So what is rest? If a body doesn't change its position as time passes with respect to its surroundings, it is said to be in rest. Motion and rest are relative terms. It means that they both depend upon frame of references. So now we are going to discuss about the types of motion. So there are three types of motion that are one-dimensional or linear motion, two-dimensional motion, and three-dimensional motion. So the first type of motion is one-dimensional motion. When an object moves along a straight path, it is said to be in linear or one-dimensional motion. For example, a car moving on a straight highway. Second type of motion is two-dimensional motion. When an object moves along a plane surface, it is said to be in two-dimensional motion. It means that it can turn anywhere, it can turn into any directions. And the third an example is a car turning on a circular turn. And the third type is three-dimensional motion. When a body is in motion in space, it is said to be a three-dimensional motion. That means it can turn wherever it wants, upwards, downwards, sideways, anywhere. For example, a bird flying in the sky. So now I am going to state the differences between 1, 2 and 3-dimensional motions. So first, 1. In one-dimensional motion, the body only uses one axis. Now two-dimensional. In two-dimensional motion, the body uses two axes. And now in three-dimensional motion. In three-dimensional motion, the body uses all the three axes. Now I am going to visually represent the three types of motion. So as I said earlier, the first type of motion is one-dimensional motion. That means it only uses one axis. So as you can see in this diagram, a one-dimensional motion only uses one axis. That means it can be any of these three axes. It can be either x, y or z. So one-dimensional motion means it's moving in a straight line. So as you can see here, if I am choosing the x-axis and draw a straight line, it means that it's moving in one-dimensional motion. So second type of motion is the two-dimensional motion. It means that an object is moving along a plane. So as you can see in here, there are two planes, yx plane and yz plane. It can be any of these two planes in which that object is moving. It means that the object is covering two axes. And now I am going to say about the three-dimensional motion. The three-dimensional motion means it is moving in space. A space has three dimensions. So it means that an object moving in three-dimensional motion uses all three axes of motion. That means y, z and x. Now I am going to say the classification of motion. So there are three main types of motion. That is translatory motion, rotatory motion and oscillatory motion. So let's first start with translatory motion. In this type of motion, the body and all parts of the body moves through the same distance in the same time. That means it covers the same distance in the same time. Now let's look on to examples. So some examples of translatory motion are a motion of a car, riding a bicycle, etc. Translatory motion can be divided into two types. First one is rectilinear motion. So when a body moves along a straight path, it is said to be in rectilinear motion. Second type is curvilinear motion. When a body moves along a curved path, it is said to be in curvilinear motion. Now second type of motion is rotatory motion. In this type of motion, the body moves about a fixed axis without changing the radius of its motion. Now some examples are giant wheel. So as you observe a giant wheel, in the middle there is a fixed point, and the giant wheel rotates around that fixed point without changing the radius of its motion. And now the third type of motion is oscillatory motion. The to and fro or back and forth motion described by an object as a whole along the same path and without changing shape or size is called as oscillatory motion. Basically, this is a to and fro or back and forth motion. So, for example, a child playing on a swing and a pendulum of a clock. There are two more types of motion that is dependent upon the distance covered by the object in unit time. So, first one is uniform motion. When an object covers equal distances in equal intervals of time, it is said to be in uniform motion. For example, a train moving at a constant speed. Second one is non-uniform motion. When a body covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. Example, a car moving on a crowded road. Now, I'm going to introduce you to distance and displacement. So, what is distance? Distance is the length of the path traveled by the body from its initial to its final position. Basically, it is the total distance covered by the body. It is the total path covered by the body. Second one is displacement. It is the shortest distance between the initial and the final position traveled by the body. So, now I am going to practically represent what the differences between distance and displacement. So, I have said you the meanings earlier in this video. So, now let's look into this diagram. So, in this diagram, there is a triangular path and each side of the triangular path measures 7 meters. So, the question is, boy travels from A to B to C and back to A. So, the distance will be, as distance is the total distance covered by the body, the distance will be AB plus BC plus CA. That is 7 plus 7 plus 7 or 7 into 3, that is 21 meters. So now the displacement. As displacement is the shortest distance between the initial and the final position of the body, the distance will be 0 because the initial position of the boy was A and the final position of the boy was also A. So the shortest distance between A and A is 0. That means he doesn't need to move from that place. So now let's go to the second case. In this there is a triangular diagram. So let's consider this as a triangular path. And here also each side measures 7 meter, 7 meter and 7 meter. So now here the question is, boy travels from A to B and from B to C. It only travels till C. So the distance, as distance is the total distance covered by the object, as I mentioned earlier, the distance will be AB plus BC, that is 7 plus 7 or 7 into 2, that is 14 meters. The displacement will be 7 meter because as displacement is the shortest distance between the initial and the final position of the body, and the initial position of the body was A and the final position of the body was C, and the shortest distance between A and C, as you can see, is AC. So as AC's length is 7 meter, the displacement will also be 7 meter.